Want to know about bromination of phenol? Well, worry not. I am here with this topic. My name is Manasvi Chaudhary, presently pursuing course B.Sc Physical Science with Chemistry in Kerorimal College, University of Delhi. The very first thing which strikes our mind is resonance. As we all know, in most of the aromatic compounds, the reason of reactivity is this resonance, and so is the case with phenols. Phenols are highly prone to electrophilic substitution reaction because they have rich electron density at ortho and para position. As you can see right over here, we have electrons on oxygen which it delocalizes in the benzene ring, and they keep on revolving, and hence due to this procedure the electron density is increased at this ortho position, which are these two, and at para position, which is this one, you can see. And due to this reason, all of the electrophiles, they attack on these positions only. And these are the figures as shown due to resonance. Now we will see halogenation of phenol. Particularly we are discussing about bromination. So we have two cases over here. First, when we have CS2 with bromine, and second, when we have water with bromine. When we add bromine and phenol at very low temperature in the presence of carbon disulfide, we get mono-substituted bromophenols. Like these two, we have orthobromophenol and we have para-bromophenol. And whereas, if we carry out the same reaction in the presence of water, if we have bromine water, then we will get the white precipitate of 2,4,6-tribromophenol. Now we will discuss these two reactions in detail in the following slides. The very first reaction is reaction with the bromine water. First, go with mechanism. The very step one is generation of electrophile. We have bromine, we have Br2 molecule. In that molecule, electrolytic cleavage takes place, and hence two of the electrons is taken away by one bromine, and it forms a Br negative ion and Br positive ion. Now what we have got an electrophile. In the next step, what we have is H2O. It will abstract the proton from phenol and it will form this phenoxide ion. Br positive ion attacks on ortho position and this compound is formed. In the next step, transfer of proton takes place. This H get attached to that O and it frees up this space, and hence a double bond is formed in between. And in the similar way, more electrophile, that is Br+, it attacks the remaining position and this compound is formed as a result. It is a white precipitate and it smells of an antiseptic. Bromination of phenol by excess bromine water is so feasible that it can take place in cold solvent in the absence of any catalyst. Third point, water is more polar. Now you will question to this that why all of the bromine gets attached to all of the electron-rich center. This is due to the polar nature of water. What this does is, due to its polar nature, it facilitates more and more ions in the solution, and hence tri-substituted product is formed. Now I'll go to another reaction, that is reaction with carbon disulfide or CHCl3. Remember, we can carry out this reaction in the presence of non-polar solvent, that is carbon disulfide, or CHCl3, that is trichloromethane. Now let us first see the mechanism. We have the same mechanism right over here, generation of electrophile. Cleavage of Br2 molecule takes place heterolytically and we get these two ions, that is Br positive and Br negative. Attack of electrophile. Now the Br positive ion species formed here, it attacks to that of phenol in the presence of CS2 and it forms this compound. In the next step, the Br negative ion formed above, it abstracts this proton and this compound is formed. And in the similar way, there are many molecules in that mixture. So what happens is, nearly 70% of those molecules, they are substituted at the para position. That means the that Br plus ion, it attacks the para position because there is less steric hindrance. And here we can see that OH group is much closer to that Br, so Br will not attack from that side, Br will attack from the opposite side, and hence para substituted product will be in more quantity. In non-polar solvents, the ionization of phenol is highly suppressed. We know that these two reactants are non-polar, and here the ionization of phenol is highly suppressed. That means the phenol is hardly it gets ionized. That I was in the previous example, we saw that O negative ion was formed there, that phenoxide ion was formed, but here there is no such kind of thing visible. So thus the hydroxyl group donates electron to the ring to a lesser extent, activating the ring slightly, and thus monosubstitution occurs. Further, due to steric hindrance at the ortho position, para substitution product usually predominates. Thank you.